Possible. So for part A, you needed to justify where the acceleration would be 0, and since this is velocity, they're asking you to find the slope and say that the slope is going to end up being 0. And so what I did, you could use mean value theorem or Rolle's theorem. So mean value theorem, you could use showing that the slope between these is the same as the, although I think that honestly Rolle's theorem fits a little bit better. So before you say that you're going to use the theorem, you do have to say that since it's differentiable, it's also continuous. You can't just use the theorem without saying it's continuous. It has to be said that it is continuous. So I said since it's differentiable, it's continuous. And then I showed that the output is the same for 0.3 as it is for 2.8. And then I wrote my special little sentence. Yeah?
You just said that it's differentiable and continuous, right? You don't specify that it's continuous because it's differentiable?
We'd have to check to see if a student did that or not, because most of the time they say, since it's differentiable, now I know it's continuous. They usually say that that's how they knew. Yeah. So by Rolle's theorem, there's some value on 0, 4, or you could say 0.3, 2.8. But I just did the whole interval such that v prime of t is 0. The next one just says to use the trapezoidal sum, and they tell you what intervals they want you to use already, so it's really just a matter of getting those written down and then getting the answer. Is that the one you guys all said you did? 2019B was good? Okay. That's funny. For C, you're trying to figure out when it's at least 60. So what I did with this one is I took that equation and I graphed it on my calculator, and I graphed a horizontal line at 60, and I went to see where it was above that horizontal line. Shall we go ahead and do that? Then we have it. So that second equation was 45 square root t cos 0.063 t squared. And they didn't say that the interval has to be from 0. No, they did. They said the interval is from 0 to 4. So what I did with my window is I made my window from 0 to 4. And then with my y max, I wanted it to be bigger than 60 because I was going to see where the curve was above 60. So make this like 70 or 80, just something where you can see it. And then for y2, I went ahead and graphed 60. And that way I can see the curve and I can see when the curve is above 60. So I went ahead and did second trace and found the intersection. So there's my first intersection. Look, Tiago, I'm taking your advice. There we go. And then I'm going to do the exact same thing again, but find that second intersection. I hopped down to the straight line because it's easier to scroll over. It'll save me 1 second, which, you know, could make a difference. Nope. Okay. So now I'm saying that I want to find the total distance traveled. And what's the difference when you're finding the calculations for total distance traveled versus displacement? Absolute value. So when I type this in, instead of doing Math 9, I'm going to go from A to B because those are the decimals that I had. Instead of just putting in the function, I'm going to put an absolute value symbol around the function. So I've got math, get my absolute value symbol in there, and then I'm using y1 because that's where I had stored the function when I graphed it. Yeah. And so that's where I got my answer from. Okay. Does that make sense now for C? Okay.
Can I get points? Like I set up the inequality and I wrote out the interval, but I didn't have the numbers.
It might be, we'll have to look and see how they graded it, if they gave points for that setup. Right, right, yeah. Well, and that's part of the problem with us doing so many things by hand, is you go, I don't know how to solve that by hand, I'm done, as opposed to, let me graph it. I put in the function VQ right here. Yeah.
don't like the two other lines. Yeah, those are, they look a little wonky.
Yeah. It's just notation. Okay, so here they said at time is 0, particle Q is at the position -90. And so they want us to use the results to figure out the distance between P and Q at 2.8. So what I did for Q is I said -90 plus the distance traveled from 0 to 8. And then for P, they said, I think they said in the problem it started at the origin. Yep, is at the origin at t equals 0. So for the other one, I just used 0, and then I used the answer that I had from B because B was the total distance traveled from 0 to 8. So point P was at the position 40.75. Oh, yeah, sorry, 2.8, not 8. So 0 plus 40.75, that's where P was. For Q, I did -90 plus the integral from 0 to 8. And then I found that location, and then I just subtracted those and got 5.188.
But it would be the integral from 0 to 2.
Oh, yeah. That's funny.
Oh, about the.
Yeah, I typed it correctly.
Is rolls included on the new side?
Rolls is the one that's like a specific situation. So it's not listed on the sheet, but you can still use it. Okay. So at this point, go ahead and switch over. Use the little grading sheet to do your best to grade for the sample responses. And then when you get a chance to grade the sample responses and then read why they got the grade they did, then you can go back and grade your own. All right, so first question, they wanted to know when the particle is moving to the left. And so we have to take the original function and find the derivative so we can get the velocity equation. And then we have to take the velocity equation and find its critical values. So this is kind of like curve sketching, but in a rectilinear motion problem. And so I found my velocity. I did 1 over the inside times the derivative of the inside, since it was ln. And then you set it equal to 0. Technically, you could also look for where the derivative was undefined, which would be taking the bottom part and setting that equal to 0. But if you do that, it's a quadratic formula problem, and both answers are imaginary, I believe, because I did that. So it ends up, you do it, and then you go, oh, I'm not using those anyway, and then you move on. Okay, so I set the top equal to 0. I got t equals 1. And so I made my sign chart. When I plugged in 0, I got that the fraction was negative. When I plugged in 2, I got that the fraction was positive. And so it's moving left from 0 to 1. Do not put negative infinity to 1 because you're on the interval from 0 to 8. So just from 0 to 1. I put a bracket around 0 because they included 0 in the interval. For number... I think this is where it gets into the, like, laid back definition versus, remember I told you guys that when I do increasing and decreasing, I do a lot of parentheses and they do a lot of brackets, and that they'll give you full credit for both. I think this is a situation where you probably could have had either.
And we could have done it with the little elevator.
Yep, you could have done it as an inequality.
Would it be 0
less than or equal to t less than or equal to 1 or less than 1, yeah. Yeah, I think, well, it comes into, so that's how I view it. I totally agree with you, and that's why I would put a parenthesis. Hold on. Yes, me, not you. But when you get into the more mathematical definition of things, then you start to include those, and I'm not super great on all those, so I don't. So if you're interested to know which one it is, you can look at the answer key, and they'll probably have the more, like, perfect definition of that, whatever. But I do know that on those problems where it's increasing, decreasing, and they have a bracket, they'll take your parenthesis answer and be okay with it. I do know that, yeah.
Why is it 0 instead of the...
Because the interval.
Oh,
Okay. Part B. So here they said where are both particles moving to the right? So what I did is I took the velocity of Q, yeah.
It's on the table.
We had to count it down.
We had to mute the TV and we didn't want Toby to get there about that.
All right, so Q, so particle Q, we set it equal to 0. Found that the two values are 3 and 5. And I did my sign chart for that. So then I'm looking to see where both of the sign charts are either in agreement that they're both moving left or both moving right. Since this one only moves left from 0 to 1, I kind of ignored that because this one was moving right at that time. So then I noticed that this one would be from 1 to 3 and then 5 to 8. So both particles are moving to the right on those intervals.
Sign charts are like.
You can use them, but you can't leave that and say, there's my answer, I'm done.
Okay.
You have to interpret the sign chart.
But you can use it as justification.
You cannot use it as justification. You could say, if you needed justification for this problem, you would have to say they are both moving to the right because V sub P of T is greater than 0, V sub Q of T is greater than 0. So you could look at the sign chart to find that they're pluses, but if you had to justify, you would have to say that they were greater than 0. So these never get to be justification, they're just an okay way to show your work. So you don't have to scribble it out. You don't have to scribble it out, you can leave it there. Yes?
Quick question.
Mm-hmm.
Do you have to, like, draw that your first sign chart again, or will they know that that's the sign chart that you're using?
You're fine. Anytime you're using, well, and probably, honestly, these probably don't get any points at all.
Oh, okay.
So it doesn't really matter. Yeah.
And
Yes.
then
Oh, sorry. You got a few.
variables, if you switch between T, if you make the T X, is that...
I've seen problems where, like, the problem was g of x and a student wrote f of x instead, and I've seen them get credit for that. I don't know about switching between x and t. But so we would just have to look and see if we could find a student who made that mistake and see if they got credit or not.
And can you, go ahead. Can you switch between x, like for this one where it was x derivative of p, t, can you switch between that and v of t?
Mm-hmm. Yeah, you should be able to switch between x prime and v because we know those are the same thing.
And the question said in the same direction, do you have to state which direction it's going? Or
I
can you
would.
just say they're going?
I would, just to be careful. Yeah.
How does that, the sign chart tell you that it's both particles?
So I was comparing this sign chart with this one.
So do you just...
This one was minus from 0 to 1, and this one was plus. So I knew that they weren't the same. This one is plus from 2 all the way to infinity. And so with this one, I knew, okay, 2 to 3, they're both plus. And then this one's plus from 5 to 8. This one would still be plus from 5 to 8. And that's how I knew. This one?
Yeah.
Because this one is plus, it's just plus on the right side of 1. So from 1 to 8, it would be plus. Yeah. Okay. Good with questions? Okay. Part C says acceleration, or it doesn't say acceleration, it says when is the speed increasing or decreasing? And we know that to find if the speed is increasing, we have to know that the acceleration and the velocity are the same sign, or if the speed is decreasing, they would be opposite signs. So what I did is I found that V of 2 was positive and A of 2 was negative, and since the signs were opposite, that meant that the speed was decreasing.
We have to find also the speed, also the acceleration.
You find the acceleration, oh, it does say that. Dang, I needed to write that. Dang it. What is it?
The signs are opposite. Or
Just
could-
negative 4? Oh, yeah, because you plug in 2.
Could, like, the fact that your answer is negative tell you that if the speed is...
To explain your reasoning, you have to say they're opposite signs. Because it says explain your reasoning.
If you said one's positive and one's negative,
That's fine.
that works.
Okay, the last one says find the position of particle Q the first time it changes directions. So what I did is I looked back up here at this work. I can see it changes directions at 3. So if I want to find its position at 3, then I have to use 5, which was its starting position. So 5 plus the integral from 0 to 3. And then I went ahead and I did my antiderivative, and I evaluated my antiderivative from 3 to 0. Now, technically, you could get it to this point right here where you plugged in the 3's and be done and not simplify.
Is it also okay if you add the 5 once you plugged in the proofs, like you add 5 afterwards because you
Yeah, you can add the numbers. That's fine.
And can you simplify some things but not all of them?
Yep. When it comes down to the numeric answer, they will take the furthest that you got it and they'll look at that one. So they won't look at the first one and go, oh, you got the first one right, your answer's right. They're going to look at the very last answer you had. And if that answer is right, they're going to give you the point. And if that answer is wrong, they're going to count all of it wrong.
So it's better to just not
It's better to
count
just
all.
plug the number in and call it good.
It goes against all my instincts.
I know, it bugs me
What if
too.
you plug it in and that's right, and then there's some wrong steps in the middle, but then you get the right answer at the end?
Then you're wrong.
So what if you were to walk over to the left?
They're going to look at the work. So if you have something wrong in there, you're done.
Okay, yeah.
Do not simplify.
So basically, don't simplify.
Or you
Yeah.
can simplify to make sure you have a number that kind of makes sense.
And then go back and cross it out. Yeah. Yep.
Okay.
Let me give out the student samples.
You just like cross.
If you cross it out, they're not supposed to grade it.